Alright, hi. So in the last video we went over the basics of Strawberry and creating a GraphQL server with Strawberry. We used Fast API as our base and added a GraphQL router provided by Strawberry. We also created our first query. We, we, we went over the basics of how to create types and queries, where we created this post type and we declared the fields, and then we created um, a query of posts which let us be able to see a list of posts in our database. However, the posts that we created are hard coded here, which is not ideal. In an ideal sense, the data has to be gotten from a database and passed in and supplied to the user. So this time around we are going to be setting up a database and we are going to be using SQLModel. Now SQLModel is an ORM, an object relational mapper. It maps our Python objects to SQL tables. It allows us to basically write SQL queries in Python. So we are going to be using SQLModel and we'll start by installing it. Now here's the link. I'll put a link to the documentation in the description. So we'll start by installing SQLModel. This is not a tutorial, this is basically me coding the stuff out but explaining what I'm doing so that to the best of my abilities. So it's not a full-on tutorial. Alright, so we are done with that. Now when working with databases, there are various operations that we can carry out. It is very frequent for us to keep adding new tables. Like for now we want to add only posts. In the future we are going to want to add a user table to the database, and we might want to add and remove and alter different things. So we need a way to be able to keep record of what we have done to our database, of how we have changed the database, a version control basically of what has happened in our database. And what is going to help us to do that is Alembic. Alembic is kind of a version control similar to Git but for our database. So we are going to be using it to keep track of the activities that we perform on our database. If you're familiar with Django, these are considered migrations, and they are considered migrations generally in any programming language, and it is a general term. The different changes you make to your databases are considered as different migrations to your database. So Alembic is going to help us keep track of our migrations. So instead of just making changes without having a history or a record of what changes have been made, Alembic help us to organize things. Alright, so we're also going to be installing Alembic. I'm here on the Alembic docs. The link will also be in the description. Alright, so pip install Alembic here. By the way, I'm using NeoVim, so any editor you decide to use works fine. Alright, so that's installed, and I'm also going to add this to my requirements.txt. So I'll pip freeze to keep track of the packages that have been installed. Alright, so the first thing that we are going to do is initialize Alembic. As I said, we are going to be using Alembic to monitor our changes to our database. So we are going to initialize Alembic, and we'll do that with a simple command called Alembic init. That is to initialize. Then the name of the folder you want to initialize this in. You want your database migrations to be stored in. So I want it to be stored in a migrations folder. So Alembic init migrations. Now that will go ahead and create a template for us. It will generate a bunch of files. So it generated these files for us. Now these files all of them have their meanings, their uses. But what I'm going to be mainly concerned about the env file, the env.py. Also, it also generated this alembic.init file. This is where you store in various variables, like your database URL goes here. So various variables for your database, various information for your database will be stored here. But I'm not going to use the init file because we want to be able to change this code with Python, and that's going to be difficult to do using this alembic.init. So that's why the env.py file exists. It allows us to be able to make changes using Python code. Say if you have an environment variable that stores your database URL, you'll be able to access it using Python code in this env file. So now that we have initialized Alembic, it's time to create some migrations. Now this is going to be very similar to Django. So I'm going to create a models.py file, and in here I'm going to write our database models, which are Python classes that represent tables in our database. So we want to have a blog or a post table. It's going to be similar to this post type here. So I'm just going to copy that and use that as a reference. I can comment it out. So we are going to be using this as a reference of the tables of the fields we want our database to contain. So we'll be creating a class of post. So we create a class post that inherits from SQLModel, and we have to import that from SQLModel, import SQLModel. A model basically is a Python class that represents a table in our database. So each model has to inherit from SQLModel. Alright, so we also say pass the argument of table equals true. This tells SQLModel that we are creating a table. Alright, so we are going to pass each field. We have the ID field, and we have the title, summary, and body. So we are going to pass, our table will have columns for that. So we are going to pass that. So we are going to pass in the field as attributes. So we need the ID field, the title field, the summary, and the body of our post. I think I'll call this abstract. Alright. Now SQLModel allows us to have basic good type hinting, which I very much like. So we can specify the type of each field here. So we have assigned the type of optional int to ID. We also assign the type of string to title, string to abstract, and string to body. So we have basically created a model, but we can add extra information to each field by calling a special field function supplied to us by SQLModel. Now here we can tell SQLModel that this is a primary key, that this ID should be used as a primary key in our database, and we can also give it a default value. So default equals none. Now there's a reason for this, for the ID being optional. As I said, these classes, the post model here, represents a table in our database. Alright, so initially when we create a post, it will not have an ID. How the ID is generated is where the post is created by the database, it will now generate that ID automatically. So in the initial state of a post, when it's being created, it has no ID. So if you try to use the ID before SQL model has talked to our database for us, you won't, it will be undefined or be none. So it won't exist. So that's why this is typed as optional, because it's originally none, then it will have a value later on. So that's the convention to follow here. We can also pass other fields, but for now I think this is good. We have a title, abstract, and body. Now we have to inform Alembic. As I said, we are going to be using Alembic to manage our database operations. We have created our model here in our Python code in our models.py. Now we are going to inform Alembic about these changes that we have made, and that's where we use our .env or our env.py file. So we are going to be importing that model. So from blog dot restart my LSP, sorry, I'm restarting it to be aware, to make it aware of the new file that we created, the new models.py file that we created here. So from blog.models, we'll import post. Alright, and then we'll import SQLModel in here. Now SQLModel will contain information about our posts metadata. Basically, it's called metadata about our posts. So we have to pass that metadata to this target metadata field. So if you go to your env.py file, you'll see you can just search it, target metadata field over here, the first one here. Now it will equate it into SQLModel.metadata. Now this will contain, SQLModel will now pass all the metadata about every table that's imported here. We imported this post table since we inherited from SQLModel initially. SQLModel will have metadata about this post table. So every model we import here, that we create, we import here, SQLModel will have data about it and pass that information over to Alembic on this using this target data variable. I'm just going to remove this post and import star. That's importing all models from our blog.models. Now the next step is to give it a URL to our database. So we are going to be using Postgres later on, but for now we are going to be using SQLite. Why? It's just because it's easier to set up. Until we need Postgres, then we'll migrate to Postgres, but for now we are going to be using SQLite. Now as you can see, if you can notice here in this run migration offline function, there is this URL parameter here, and it's collecting this SQL Alchemy URL. This URL represents the URL of our database. It's collecting this URL from our alembic.init file, right? This config.getMain function basically is searching for this SQL Alchemy.url. From here, there is a alchemy.url. Yeah, there is a variable here called SQLAlchemy.url, and that's where it's getting that URL from. But we don't want that. We want to be able to set our own database URL from within our Python code. So we are going to be creating environment variables, because our URL can be different for development and for production. If you are going to push our code to production, the database URL can change. So that's the reason why we are going to be using environment variables, so that whatever, the code will remain the same, but we can pass different environment variables to it. So we are going to be creating our environment variables, and it will be stored inside the .env file, .env. Now we are going to add that to our git ignore. So we'll open our git ignore and make sure that .env is there, because we don't want to accidentally push this file to GitHub. This file is going to contain secret information like our database URL, potentially our database password, our database username, and whatever other secret information that you don't want to be shared by other people, right? So this file is going to contain it. That's why we want to add it to our git ignore, so that we will not accidentally push it to GitHub. All right, so we are going to be creating a variable db_url, and it's going to be equals to whatever the database URL is. All right, so I was just checking on the formats on how SQLite databases are created. So we have this format here. The syntax is basically the driver followed by column // then the path to whatever SQL file your database is stored in. So we are going to be writing that. So SQLite, and I'll call MountDB.SQLite3. all right, so now we have done that. We need to get this environment variable is set in this .env file, right? So we need to inform our app about this, or we need to get this from our Python code. So in our core, I'm going to create a settings.py file. All right, so we'll create a settings.py. Now this will contain all our information, a lot of configurations for our project. I'll be using a package called decouple. This is going to allow me to easily access environment variables from within my Python code. So we'll be pip installing Python decouple. Alright, pip freeze requirement.text once again to update our requirement.text file with our latest installs. Restart my LSP. Alright, so from decouple, I will import config. Now this function allows me to access environment variables, as I said. So I'll create a variable db url will be equals to config, then the name of that environment variable. As we see here, we named the db url in our environment in our .env file. So pass it there, and we'll pass it a default value of none. Right, now I'm going to create a settings class. And there's basically one reason for this. So if db url is none, I want it to raise an error. db url environment variable not set. The reason for this is to prevent exceptions, to make sure that our environment variables are already set, or make sure we do not forget to set our environment variables basically. Alright, so basically what I just did here is to make sure that whenever we want to use this db url, we'll ensure that we have already set that db url, and then we'll pass it to self, so we can access this any configuration inside here from this settings class to prevent errors basically. So we can go into our env.py for alembic env.py file, and we can change up this url settings here. I'm just going to comment this one out. Our pass URL equals to our setting class from core.settings .dburl. Sorry, we just have to make this a string of type str is equals to string. Alright, okay, so we have our setting.dburl here, and now we are passing our database URL. So it's getting this URL from our environment variable at env.py file, and we are using via Python, we are getting the environment variable and passing it through our URL. Alright, so the next thing to do is actually create our migrations. So we'll use Alembic once again. Alembic revision. We are creating a new revision to our migrations. Now Alembic has an auto generate function wherein it will auto generate migrations for you based on the modules you have created, based on the modules we imported from here, and based on the metadata that got it from SQLAlchemy that we passed here. So we auto generate those migrations for you. So auto generate, then -m, just like your git home, git commit message. So you pass in the message. So we are creating the post table. Alright, we get an error. It turns out that I might have been wrong on how to set this URL settings over here. So how you actually do that is using this config that has been created up here. So we'll come down here and call that config function, or config. We'll call an attribute on that config object. So config.set main option. So we'll set main option. Now the name of the option. So SQLAlchemy.url. I say this URL, this variable exists in our alembic.ini file over here. So we are resetting it from within our Python code, and then followed by the value we want to set it to. So that will be our setting.db URL. Alright, and that should work now. So we can save that. Alright. Okay, so we can do that. Alembic auto generate create post, and it auto generates that that table. If you go into, as I said, alright, if you go into this migrations folder, into this folder called versions, you should see a file containing a similar name to what you the message, the /m argument you passed, the -m argument you passed. And then inside that file, our database migration exists. So we have an upgrade function and a downgrade function. So the upgrade is the changes we are making to the database, and the downgrade function contains ways to reverse from that changes if we ever need to. Now if we notice, we have some errors over here. We have this SQLModel dot SQL type something. The SQL model is not defined here, and we can easily fix that because we're using SQLModel. SQLModel has its own built-in auto string. This auto string, it basically prevents, if we noticed, when we were creating our model, we just passed in the type of string. We didn't pass in a string size. We didn't, like, a max length, which is common in database operation. If you're creating a char field, or basically a string field, you have to pass in the character length, but we didn't pass in that character length, and that's what SQLAlchemy, this auto string function, does for us. It handles the character length operations on, or resizing or increasing whatever character length that is necessary. So that's what it is, but it is not imported on here, and the reason for that is because Alembic has this script.macro, which basically contains kind of templates of how it will create that file, how it will create whatever this migration file is. So from here we see the things it's importing. It's importing Alembic and SQLAlchemy, and if we go on here, we can see that it imported those things over here, and it's creating the upgrade and downgrade function. So anything we want to be get imported, we pass it into here. So we can write import this stuff over here, right? So we import that, and we can recreate our migrations. We can delete this previous one and recreate it again. So Alembic revision -- auto generate -m followed by whatever message it is that you're sorry, I made some errors in my settings.py file. Alright, and goes and generates that migration for us. So if we come in here, once more. We can see we don't get any errors because it imported that SQL model SQL types from there, and that's it. So you can definitely write this migration file yourself. I mean, all you have to do is create this table. Okay, we create this table over here, name it post, then we create a column. The type is an integer, it's not nullable. We create a title, which is this SQLModel auto string that handles the char field setting for us, and then it is not nullable as well, and the same thing is repeated. And then we now declare the ID field as the primary key. So these things are obviously very creatable by yourself, but SQL Alembic provides a way to auto generate it for us. Alright, so we have created our migration. Now we have to make those changes to our database. We specified our database URL here, but we don't have any. Oh, alright, so Alembic went ahead to create our database for us, the one that we specified here. Alright, now we can migrate, actually applied. We have created our model, but that model doesn't exist in our database. If you go to, I do have SQLite browser. If we enter our browser to browse our database, okay, open database. So we can go to where this folder is SQLite SQLite browser. You can install it for whatever system you want. So we can basically use this function to observe our database and how it's changing. So if we go to our SQLite browser over here, we can see there is nothing here. There's only the tables that Alembic created for us. This is what it's using to manage our database migration, to know which migration has occurred and which one has not occurred, right? So but our own blog post table that we created has not arrived here. So to actually push, or basically like a git push, to push those changes to our database, we need to run another command. So Alembic upgrade head, similar to how git works. We are running our upgrade function, and we're upgrading the last migration, and it's pushing those data changes to our database. And if we refresh, is there a way to refresh this? Alright, if we refresh it, we see our post table, and it has the fields that we specified here, and we are good to go. We have set up our database successfully, and we have migrated our changes. So now the next step is to be able to use that database in our application. So let me close a bunch of these files that we don't need. Alright, now we need a way to create new posts, because we are going to be jumping into mutations, which are ways to change things on your server, right? It can be a delete operation, it can be a create operation, it can be an update, but as long as it's changing the state of what's on your server, I consider it a mutation. So we want to be able to change things on our database with SQLModel. So how are we going to set that up? We are going to define a function under this our post model here called new. It's a simple way to get things started, right? So, and we also make this a class method, right? Now the reason why it's a class method is because we don't want to have an instance of the class. We don't want to have done something like this, posts then dot new here. We don't need that, because this means that we have already created a post instance, and then we are calling the new method of that instance on it. No, we want to be able to, from the post class itself, call this new method, right? So that's what we want. Now what we are going to do, we are going to ask the parameters we need to create a new post. So create a new post, we need our title, which is a string. We need our abstract, which also a string, and we need our body, which also a string. Now anybody that calls this new method must pass these various things. Okay. So when we are creating a class method, we don't use self, we use class to reference the current class, that is this post class over here. Alright, so the next step is to actually create that post. So it's very simple in SQLModel. So we create an instance of this class. You can say create a post like this, or you can create class, since this class refers to this post over here. So I'm going to be using this class. So class, I'll be passing the title equals to this title variable that's going or argument that's going to be passed here. In the abstract is going to be equals to this abstract, and the body is going to be equals to the body that we passed. Oh, I misspelled abstract. Now this is going to we are now going to see one of the flaws of SQLite databases over here, because now I've changed the spelling of a field in my table. Obviously we can go and create a new migration for it. So alembic revision -- auto generate -m. So we say updated post abstract name, just naming what operation we are carried out. And alembic will obviously will generate that migration for us, and we can go here, we can see what he has done. He has dropped the abstract, the misspelled. Is going to drop the misspelled column, and it's going to create the new column that we are creating now. Now if this is not what you want, like if you have a whole table or a whole column in your database that's actually populated with data, right, I don't want it to just be dropped, now you can come into this migration and edit things. I don't know what you edit, I'm not an expert, but you could do that. So it's going, we don't care, since we don't have any data in our database. But if you did, I don't want to lose data. If you already had a couple of posts and you don't want to completely drop the abstract section of those posts, you could come inside here and edit whatever needs to be edited to rename, instead of dropping and adding columns. But I'm fine with this. But the issue comes when we want to upgrade. We get okay, we didn't get an error. That's because we don't have any tables in our database. We have not created any fields in our database. But on a usual basis, I've gotten this error before. We'll complain that SQLite doesn't have an alter operation. That means you cannot alter fields tables that have already been created. Meanwhile, you can do that with Postgres freely. We didn't experience that error now, so good. Alright, so we have renamed that field and fixed that typo, and we have created this class, this instance of this post. As I said, you can name this post, let's name it post for clarity, and we can call it new post is equals to post. So we have created this post. Now what do we need? What else do we need? How do we translate this Python code we have written to database tables? To do that, we need a session, right? We need a database session. So with session, this session class is provided by SQL Alchemy. This is for each operation that you want to perform on your database. It is advised to create a different session. So this session represents a singular operation, right? Now we want to create a post. That's an operation. We need to do it in a database session. So we need to open a new database session. Now there is this open, I don't know how to do that. There's the open um, function or something that you can open a session with and things like that. But then after which you have done your operations, you now close that function. But it's kind of a hassle, and the advised way to do it is with this with statement. This with statement means that we are opening a new session, and when we pass in a semicolon here, like we are like an if statement or something. So we are opening a new session, and within this indented block we'll perform all our operations, and when we are done, this with call will automatically close that session, so the session will just remain open, right? But we can't use the session as we have created the session. We need the session needs something. If we hover over this session info, we see that it needs this bind um argument to be passed, which is a connection or an engine, right? So we need to pass an engine or a connection to our own database, because this session now is not connected to our database, so we need to pass a connection to that. So we are going to create that connection. We'll go once again to our settings.py file, right? So from no, I'll just do that in here. Okay, anyway, so db we'll call a variable called db engine, and I'm going to explain a bit. So equals to create engine. Now this create engine function will create an engine, or you can call it a connection, to our database, right? So we need to pass it a URL to our database, or the link to our database. Then it's going to create what? An SQL engine. So we need to pass it that link. I'm thinking I'm going to rename this function to get db URL, right? So that it will not, if I ended up putting this function in here, the way I'm imagining it is that this create engine function is going to run anytime someone calls this settings class, and I do not want that. So no. But let's just place it outside this function. Alright, since it's not an environment variable, let's place it here. So db engine equals to create engine, and we need to pass it that URL. So we are going to pass it our setting .db URL, right? So we now have this engine, right? This engine, we can pass it to our session over here. So we can pass in db engine, which is going to be automatically imported from core.settings. Let's remove this. Alright, so we have created a session, right? Then we need a way to reference that session as session. So this session is basically a variable that we can use to reference this session that we have created. Okay, so we have this session, right? It's basically a session. As I said, we are performing a creation, a new creation action, right? For each action we need to create a new session. It's recommended I'll create a new session. All right, so with this session we are going to create our post. So I've already created an instance of this post here, right? But we need to pass it to our database. So we'll say session.add, right? New post. So this session.add will add this new post that we are creating to our database. We'll carry out the communications to our database. Then, as I said before about this ID field, this ID field is still none. Even if you go to access this ID field .id here, it's still going to be none, because even though this session has added this post to the database, this post is still not having an ID because we didn't pass in an ID here initially. So what we need to do to make sure that we get back that ID from the database is to refresh it. So this session has a method called refresh, where we can refresh this new post, right? And returns none. So now if you access this new post.id here, it will contain a value. The type is still int or none, but now we can safely access it and know that, yeah, the ID is now passed in because we have visited the database here and we have refreshed the new post, and now new post has value ID. All right, so when we create a post, we want to return that post instance. So let's indicate a return type here. Now we can type post, but that won't work because this new method is being defined within this post function itself. So this post function technically doesn't exist yet, right? So the way we are going to do that to say that we are returning a new post is we'll return self. Self is imported from typing. So from this typing module, we import self. So this self is referring to the fact that to this new post. So we are saying this function is going to return a post which is the parent of which is the class in which this new is a class method, right? So we need to return that post. So return new post, and we are done. We have basically handled creation. As I said, simple, you create a post instance. Post, we pass in the attributes title, abstract, and body, right? And then we assign that to a variable called new post. We now created a session, which is a database session. This database session takes in what? A binding of connection or engine, right, or none. But we have to pass in a connection or engine for it to be connected to, say, to that particular database. Then we created this engine, right, with this create engine function that is passing from SQL Alchemy. It takes in an argument called URL, which is a string or a URL object or so. Then we pass it the string. The string is our setting.db URL over here. That's the URL we set in our environment variable, right? So that's what that engine was all about. And then we now set our session to be as a variable to be able to reference this session we created over here. Then we use that session to add the new post to the database, and we then refreshed our Python object with the data from that new post that has added to the database. So here we can now access the ID, which was originally not existing but now is existing. All right, and then we return that new post. So simple, about four steps over here, 4 simple steps, and we have created our post, our new post. So now anyone can use this method to create a new post. All right, so we have created this function. We need to be able to access it through our GraphQL server, right? To our GraphQL mutations, because our mutation is what users will have access to. Users don't have access to our post model directly, but you have access to our GraphQL mutations and queries, right? So we need to create that mutation so that they'll be able to create a new post. I'll close some of these, close these migrations. All right, so we create a mutations.py file, and in here we are going to define our mutations. Our mutation is basically a GraphQL type, just like our query. So it has to be decorated by our strawberry.type, and our class will call it blog mutations, right? So we have our blog mutations. We need to create a field for new post. So since it's a field, that is a function that can be carried out by this blog mutation, we have to decorate it with strawberry.field, right? It's a field on this blog mutation type, just as this ID is a field on this post class. or an attribute on this post class. In GraphQL, they are called fields. This is a field. This is a blog mutation type, and whatever we define here is going to be a field on that type. So we define a new post method. It inherits from self, right? And it takes in various values. It takes in title, which is a string, takes in abstract, also a string, and it takes in the body of the post, which is also a string. We are defining a mutation now. As I said, a blog what am I saying? Mutation. Okay. Sorry, so this is a mutation, so it has to inherit from strawberry.mutation. Alright, so we are saying that, okay, since it's an instance of this block class, it has to have this attribute of self pass. We are saying we need a title, an abstract, and a body to be able to create that post, and we are going to return a post type. Now this post type is obviously it doesn't coincide with our database, in that we have summary here, but in our database we renamed it to abstract. So let's rename that. Alright, so here we go. We have to return a post type. Alright, so we need to create that post. So all we have to do now is call our post model and that new method on it, right? And we need to just pass that title equals to title, abstract equals to abstract, and body equals to body, and we have created a new post. So let's name it new post. So new post is equals to this. So we have a new post of type post. This new function will perform the creation operation and will return to us a new post. But we can't just return this new post. Why? Because this new post is an SQL model, and what we need to return that GraphQL will understand is a post type, right? So we need to convert this new post into our post type, right? So there are many ways to do this, but I'm just going to define a function called model to GraphQL, right? And it's going to take in some variables, but let's just pass for now. It's going to take in some variables. It's going to take in the it needs the model type, it needs the GraphQL type, and the model instance. So what I mean by that, in this our case, this is going to be post type, and this new post variable that we created over here, this one. Alright, so those are the three things it needs. I'm not really sure about this model type, but let's start defining it and we'll see. Now, since there are going to be many model types, we can be creating a post now, but in the future we want to create a user. We are going to use a generic. So let's create a type var. So let's name it m is equals to type variable. This is a way you can create generics in Python. M. So this m represents our model type, and then our GraphQL type of g, another type variable, and we'll name it g. Now we want to make sure that this our model type is bound, is a child of SQL model. That means it's actually a model, right? So we can pass a bound of SQL model. So they will never be able to pass in a type that is not an SQL model, or it's not bound to SQL model here. Alright, so as I said, here we need type. A type is different from an instance, right? So the type of post is different from an instance of of post, right? This here is a type, a post type, while this here is an instance, and here new post is an instance of this post type, right? So new post and post are kind of, the post is the blueprint or the class type, while the new post is an instance of that class type. So we want to pass in the type itself, not an instance. So to do that, we use this type. Okay, so let's say it's model type, and we want to specify that it's going to be the type, a type, not an instance, a type of this model, of this m type variable that we specified here, right? So we have that. We need the GraphQL type again. We need the GraphQL type. So we say GQL type is going to be a type of this G type variable specified here, and then we need the model instance. So instance, and we'll just pass it m. That is an instance, it's not a type, it's an instance of that model. And at the end, when we are done with whatever we do inside this function, we are going to return an instance of that GraphQL type, right? So that is, this function is converting an instance of this model type to an instance of this GraphQL type, and it's returning that instance over here. So we are going to perform whatever magic that we are going to use to do that inside this function. All right, so first things first, we need to get the fields on that model. So our model type has an attribute called fields, right? So let's see if our model instance, okay, no, our model type has an attribute called fields, right? So now and it also has it also has a field, an attribute called SQLModel relationships. This field represents our fields here, right? And this SQLModel relationship is going to represent a relationship. For example, if a post has an author that that references, say, a user type, right? So this relationship of post and user over here is going to be stored in this SQL relationship attribute. But since we don't have relationships now, let's not deal with that now. Let's just deal with the fields. So we say for field in these fields, right? If our GQL type dot, or if it has attribute, if our GQL if our GQL type has attributes of that field, that means, so for example, this post type over here, right? So if our post model has a field of ID and our post type has that same field, right, we are going to know that, okay, we can add the value in that post model to that post type field. So we need to do something. We need to store those values inside, let's say, quarks is equals to this, right? So let's say quarks field is equals to model type dot dict. field or none. Alright, so what's happening here is that for each field in our model type field, right, we check if our GraphQL type has an attribute of that same field, and we create inside this our quarks that we created up here, we create a new dict, or a new a value here with the key of that field name, where we pass in the value right from the model type. So model type.dict will contain the values inside that model type. Okay, this is not model type, this should be instance. Change. So it should be instance dot alright, I said for each field in our model type fields, right? So if our GraphQL type has that attribute, a similar attribute to that field, right, we'll pass in our keyword args. We'll create a new instance with the key of that field name, and the value will be the value, that value in our instance. That is, if six, for example, ID, we'll check, okay, field, our model type field has a value ID, right? If our GraphQL type, that is our post type over here, also has an attribute ID, which it does have here, right, we'll pass in our quark. So our quarks of the key ID will be equals to our instance.dict.get. That is, from our instance we will get the value of that ID, or none, right? So that the value will be none if it doesn't exist. That's okay. And then at the end we'll return GQL type, and we'll pass in those quarks. What was the sense? A function with declared type must return on all code. Okay. Yeah, we just need to remove this from our for loop, and that's all. Now the reason why I did this, I could have just come here and said we could have just say created our GQL type instance here, right? Let's say GQL, and then we could have come and set attribute of this GQL instance, and passing the field name and the value, that is instance.dict.get field or none. Now why I didn't do that is that if, for example, which is going to be the case, there's a required field like title or abstract here, right? The moment we create this GQL type and we do not pass in those required fields, it's going to throw an error that we are not passing in the required fields, right, to create this GQL type. So we will not be able to reach this point where we actually then set those values. So that is why we get those fields and we store them in a temporary quark variable, and then we now pass in all those values immediately at once to the GQL type once we are creating it, and then we automatically return that GQL type out. So that's the implementation. Let's do that here. So we need to call model to GQL to GraphQL. We need the model type, which is post, right? We need the GraphQL type, which is post type, and we need the instance, which is new post. I will just need to return the result of that, and our error goes away because this function will perform all the conversion from our GraphQL model to our SQL model to our GraphQL type. Alright, so we can go and try this out, but first, as this mutation only exists in our blog folder. Our main application in main has no idea of this mutation, and if you come back to main, you can see that we are getting the schema from core.schema. So we can go there to our schema. This schema is getting only query, so we haven't passed in any mutation. So let's create a mutation. So at strawberry dot type, right? So class of mutations, then we are going to inherit from blog mutations, and we'll pass. So every mutation we have defined in our blog, let me start my LSP. So every mutation we have divided in our blog mutations will automatically be inherited by this mutation here. And then we can come here to our schema and pass in the mutation equals to mutations, and then all we have to do is start our server. So source, what I did is activate my my virtual environment, and then we can use UVCon to run our server, and hopefully if there are no errors, it should start successfully. Oh no. Alright, so let's refresh here. So localhost / GraphQL. Okay, so we can come here to our docs and see that we now have mutations here, and we have this new post mutation over here. Now let's close our docs and let's test out creating a new post. I'll also check to see if the post does arrive at our database. So let's first of all let's execute SQL. So let's select all from posts, right? We see that we have 0 posts. There are no title, body, abstract, whatever. Everything is 0. So let's come here, let's create a new post. So mutation, we are defining a mutation. Then we'll pass in a name of new post, right? And then we'll pass in inside within these curly braces. You can click Ctrl space to see all the options pop up. New post. Now since this is a mutation, we need to pass arguments to this function. We need to pass the title, we need to pass the abstract, and we need to pass the body, right? But we need, where are we going to get those from, right? We can straight up here say our title is going to be let's call it test post. Our abstract is testing post with testing post creation, and then the body can pass in the body of creating a post that will actually get saved in the database. Alright, and then within new curly braces, after the creation has occurred, what do we want to get returned. So I want all the fields to get returned, so let's just pass in all the fields, and that's that. I'll close down these guys. Let's run that mutation. Oh, we get this error, and I know why that is caused. So let's go to our new method in our model. Now, as we created this new post, I added it to the database and we refreshed it. There's actually steps between this place, right? This session.add doesn't actually commit the thing to the database. I guess it kind of does a prep. So we have to add the session.commit function, which will now commit this add. Let's say this an add operation that we're saying we are going to add a new post, right? We are telling it that we're going to do that, and then this session.commit actually then commits that new post to the database, and then we can now refresh it from here. So we missed a step. Now we can go back to missing true. Okay, so this is that error that I was talking about. Where's our mutations? This is that error that I was talking about. If we created that GQL type instance here in the first place, right? But it seems that this quags isn't getting populated. So let's print out these quags and see. Let's pprint. So let's from pprint import pprint. So let's pretty print this to see what is actually in our quags. Alright, so in our quags we have our ID, and we are missing some required stuff, which is weird. So let's go to our poster. We have title body and abstract. Okay. So I think this if has attribute is not doing its job. Let's just leave it for now, and let's just run this, and we get our post being created. Right now, I don't know why it has attribute is not working, but it means we have to add a new field to this a new argument to this function, which is going to be fields, which is going to be a list of strings, Now the reason for this is that there are some fields that exist on our model that we don't want to expose to our users here, right here, because we are passing in the ID, title, and abstract. Imagine if we are storing a user and we had things like other fields that we don't want people to know about, like say the user's phone number or confidential information stored, right? We don't want to automatically expose that to our API. So this fields variable here is going to limit the amount of the fields that we want to that we can make public on our API. So we are going to put an if condition here. So say if field in fields, right? Only if that field is in the fields that the user has passed in here, then we will now add those that argument to our quags. First of all, let's see what our quags is here. So here in our quags, we actually do get the abstract, body, and title. So let's use that method instead. So if the field is in fields, then we now update our quags, and at the end of everything, we return our GraphQL type. So let's update that here. Fields is equals to, we need the title, we need the abstract, and we need the body. We also need the ID. Right, so passing those fields over here. Now let's create a new user. I've created test post, testing abstract, and I realized this is ID3 because the first two failed, but they were actually created, right? So that's why we ended up with 3 posts instead of just one. So now as you can see, we are passing the hard-coded, it's kind of a hard-coded value in here, right? We don't want to do that. There's another method for us to pass in the values rather than just writing them in here. So we can create variables within this while we are naming our mutation, right? This new post, we can pass in variables there, and those variables must be prefixed with a $sign. So let's say the variable of title, and the type, you must pass in the type. So it's a string, right? And if it's required, that means the person must pass in the type. It has to have an exclamation mark at the end. So the title of this title is a string and it's required. Yeah, so we can also pass in the abstract here and a required string, and we can pass in the body, right? The body is also a string that's required, right? Now here, instead of passing those test, post, and whatever, we can just pass in the title, pass in the abstract, and then here in this place of this long body, we just pass in the body. All right, but now how do we actually pass in the values that we want? We can come here. If you come down here, we see a variables tab here. We have a tab for headers and we have a tab for variables. So if you click on the variables in here, we can write all our variables, so we get automatic auto completion. So title, there's a new test post. Sorry, I'm bad at naming post. So abstract, testing the post with updated logic, and then body, let's pray. So hopefully everything works fine. All right, so let's create that, and we get our new post here. So everything worked fine, our prayers were answered, and our method here works, right? This function that we created here, right, it seems to be working. So we are going to, let's add that function to our utils. Let's create a utils utils.py, wherein we are going to add this model to GraphQL function. Can remove this pprint. Okay, I want to see. Okay, so it was actually printed. So we can remove this pprint statement over here. We need our type. So all these stuffs we imported over here, let's bring them over. And these guys, I can also remove you. All right. So our model to GQL function is normal here, but let's also update, let's also refactor this rather than having these fields here. Let's put it in our model. Let's define a GQL method, takes in self, and it returns post type, right? So in here we will now call model to GraphQL on post, right? On post type, we want to return post type. We need our fields, so let's get our fields from here. And since this is, since it's a constant, let's name it in capital letter. We're passing fields, and then we can pass in self, right? And then we just return this. So return the result of this model.gql. Let me restart my LSP. Alright, so we have created a GQL method that we can call on our post. So once we create a new post, we can now call GQL method that will convert it to GraphQL. Okay, so we don't have to do this anymore. We can just return new post bar, right? Post.new.gql, which will convert it to a GQL, a GraphQL type that will now be returned by this post. And now this our function looks more pretty, and everything should work fine, obviously, and that's nice. So we have to update our query. Now this query is still using our demo post that we created earlier. So let's change that. Let's fetch the post from our database instead. You can close all this. Now let's define a new method. Let's say all, right? CLS, let's make it a class method. A class method, right? And it's going to return a list of self. That is a list of posts. Basically, self here refers to posts. So this all method is going to return all the posts, right? So with, as I said, each operation you want to perform, you ought to pass in a new session, right? So we are going to create a new session with session as session. Remember, the session needs to take in an engine or connection to a database. It's with this engine that will be able to say, okay, this is the specific database we are doing this operation, we are performing this operation on, right? So within inside this section, we can now write our SQLModel code that will do whatever function that we want to carry out. So we want to select data from our database. So we'll use the select function provided from SQL by SQLModel. What do we want to select? We want to select posts, right? This post class that we have over here, right? We want to select post. We can also just say we want to select class, because as I said, the class refers to the post. So we want to select posts. Then if you want a specific filter, like where the ID is equal to a specific post, an individual post, where post.id is equals to 1, you can do that, but we just want all the posts, right? So we'll call this a statement stmt. Let's do that. So we have statement equals to this post. This is just a simple SQL statement. We can print this to see what it does, right? So we have this statement, right? What what is this? Okay, we need to forget to pass in the return this. All right, now with our session we can execute this statement, session.execute this exec function. We will execute this statement that we passed in, right? Dot, after I execute the statement, all the posts it gets, we can say we need just one, or the first one, right? But we need all in this case, so it has an all function, right? We need all posts that it was able to find, and we just return that. So we return the session executing this statement which selects all posts, right? So when it selects those posts, do we want like the first one, right? We don't want first. So there are other methods there, but we just need all. We need it to return to us all, so we get all the posts. So that is how to select perform a select statement. And now this printing is just going to print to us what that selection looks like on our terminal, what that select statement looks like. So let's go to queries and update our queries function. So posts, we can just say post dot import that post dot all, right? It returns to us a list. So let's say post, it returns to us a list, right? Now we need, as we see here, we cannot just return the list of posts. We need it to be a GraphQL type, this post type. So we can create a variable here called post post types. That will be a list of post type, right? Then we can now loop over this. So for posts in posts, right, we can return post type, right? We can append to that post type that post.gql method. So this will return the GraphQL type of that post, and then we can just come here and return posts. Let's name this to types. Let's run. And we can return the post types. So for each post in this post that are returned by this all method, we append to post types that post.gql, this GQL function that converts it to a GraphQL model to a post type, and then we return that type. So let's retry our queries. Let's refresh here. So what? Okay, so we need a query of posts, and here we call the post function. What do we want from the post? We want the ID, we want the title and abstract, and here we get all our posts, right? Very easily, few lines of code. Here is that statement, the statement in our model, this statement that will print. That's this select post statement over here. This is what it translated to in SQL. So select post ID, post title, post abstract, post body from post. So SQLModel just builds out the SQL query for you and then runs that SQL code for you on your database, and it performs that action. Alright, so that's that with that. Now just one last thing, we can make this new post function a bit more good looking, if you ask me. So we are going to do that. Let's just comment this out and use as a reference. We are going to be doing somewhat of, I guess it's called functional programming. I do not know, but I love it. So we'll return a list, right? Or let's start like this. There's a function called map in Python, right? What does map do? It takes a function, right, and an iterable, and it performs it carries out that function for everything in that iterable. So the function is supposed to go here. So in Python, if you want to define one line functions, just like arrow functions in JavaScript, you use lambda. So lambda will take a post and return the post.gql. So this is the function we are going to run as a lambda function. What are the posts? Where are the posts? We pass in those posts. So posts dot all, right? And this map function returns let's say result equals to, it returns what? A map object. If we check here, we see it's a map object of post types, It is not actually a list of post type, right? It's an iterable or a map object, but we want to convert that to a list, right? So as I said, the map function takes a function, this function over here. We say lambda, right? Lambda is the way we define one line functions in Python. And what is going to be passed in that? Arguments that are passed to this is very similar to saying define post gql, and we take in a post, right, and we return post.gql. This here and this lambda function, they are very similar thing. The difference is that this one over here is named post gql, while this lambda function here is not named, right? So these are they perform the same actions, and that's what this lambda function is saying. For each post here, I want you to return the post.gql. Then where did those posts come from? Is this iterable post.all. So you'll pass in for each value in this posts.all. You know, this post.all returns a list of posts, right? For each value, this lambda function will be called, where for each post it will return the posts.gql, the GraphQL conversion or the GraphQL representation of that specific post. All right. So, but as I said, this result returns a map object, which is not, we cannot return this if we try to return this. We can't do that because a map object is not a list. We said we want a list. We want to return a list of posts right here, right? So it's very simple. We can just wrap this map object within the Python list function, and we are done. Within this one line, we have basically done everything that we did in this how many lines over here, and we have reduced the function lines by a lot, and it still performs the same way. If we call it, we get our list of posts. Very nice. All right, so I find myself using this method quite a lot. I just like it. I do not know why, but I prefer it. All right, so that's kind of an introduction to how to SQL model. You can obviously do quite a bunch more with SQL model. You can perform updates, a lot of things. I'm just skimming the surface. I didn't even touch a bunch of things in this documentation have not been touched, right? And I realized that we haven't been looking at observing it from our database browser. So if you run this query, we can say that, okay, yeah, we have these 4 posts here on our database that have been populated. So I think that'll be that for this video. Thank you all for watching. If you do watch it, if you like it, feel free to like the video. If you enjoyed the video, feel free to like it. And if there are pointers, if I'm too fast, if I'm too slow, if I'm too stuttery, if I am saying a lot, please do feel free to comment, put those in the comments for me. I thank you so much. Have a lovely day.
They tell me that I'm never gonna make it. They want me to do something that hate when I keep dreaming I'll be famous, but I don't give a fuck, I'ma keep chasing. I got all this potential that's deep inside of me, but they hate when you're successful cause they try to be. They sit there being judgmental because you're trying things, and they just want you to settle and do the right thing. So get a good job.